Consider a somewhat similar question. So as part of an endurance race, Stephanie needs to swim from X to Y across a wide river. So let's say this is the river and it has a width of, say, 80 meters. And Stephanie is now at X, intending to swim to Y, which is here, and across the river. So in still water, it's given that Stephanie can swim at 1.8 meters per second. And the river, it's flowing with a current, a river flows with the consistent. And also, there's a current flowing down the river at 0.3 meters per second. So the first question that we need to do is to find the distance from X to Y. So we need to find the distance here. Oh, and I forgot. There's another clue that's given here, which is the distance between this and this is 20 meters. So the first question, in order to find the distance xy, we need to consider this right angle triangle over here. So we know that we need to find the hypotenuse, which is the xy squared is equivalent to 20 squared plus 80 squared, because these are the two sides. So this side is 80. To get the value of xy squared, we need to have 20 squared plus 80 squared, which is equivalent to 6,800. And to get the value of xy, we need to square root the answer, which would give us, say, if we change it to decimal, 82.46 meters. So that's the answer for A. To solve question B, in which direction should Stephanie aim so that the current will push her onto a path directly towards Y? So we know that Stephanie needs to swim from here to here, and there's a current going that way. So from the questions we learned previously, we know that now Stephanie needs to slightly aim further down this way, so that when the current takes her to the right, she sort of could like reach her intended destination. So the question is, in which direction should Stephanie aim? So in order to get this angle here to determine the direction, maybe we could first get the value of the smaller angle here. In order to get the value of the small angle, we know that this side is 80. So to get maybe angle theta, we can consider doing tangent theta is equivalent to opposite over adjacent. So to get theta, we have to shift tangent 20 over 80, and therefore we will get shift tangent 20 over 80. We will get an angle of 14.04 if I simplify to two decimal places. So it means that my theta is 14.04. So if this angle is 14.04, how can we find this angle right here? In order to find this angle right here, we have to use the sine rule. In order to get the sine rule, we need to get this angle here. So we know that if we add 14.04 with 90, we can find that this angle here is 104.04. We sort of know that the speed that Stephanie can swim in still water is 1.8 meters per second. So this is the speed. The reason why I'm writing this blue is because I want to separate this out from the distance. So this is the distance And we should not mix the two together because it will become really confusing and it will give you the wrong answer. So now we are taking speed and the speed of the current, which is 0.3. So how do we get this angle here? We know that using the sine rule, the sine of 104.04 over 1.8, which is like the length that's opposite of the angle, is equal to sine, we'll call this as phi. So phi, sine phi over 0.3. In order to get sine phi, we can do sine 104.04 divided by 1.8 times 0.3 to get 0.1617. And in order to get the phi, we can shift sign the answer, and therefore we know that phi is 9.3 degrees. So we know that this phi is 9.3 degrees. So to answer the question, which direction should Stephanie aim, we can add these two angles together. So by adding the first angle and the second angle together, I can get plus 9.3. I can get 14.04 plus 9.3. I can get 23.34. So it means that Stephanie should aim to swim 23.34 degrees to the left of. So it means that Stephanie should aim at 23.34 degrees to the left of the strait across the river. So the third question is, find the time Stephanie will take to cross the river. So we are familiar that of this triangle, which is like, this is distance, and this is the speed, and this is the time. So in order to get the time, we need to consider the distance over the speed. For Stephanie to cross the river, her actual path will be this black line over here. So we know that the distance of this line is 82.46 as found in A. So what we need to consider is also the speed of Stephanie, so which is this line here. So we can actually do a sine rule to get the length of this length here. So from just now, we know that this angle right here is 104.04 and this angle is 9.3. So what is this angle? So in order to get this angle here, we can use 180. Take 104.04, take 9.3, and we will get 66.66 as the angle. So in order to get the speed here, we can actually use the sine rule. So sine 66.66 divided by the distance, let's say the distance z, is equal to, so we have taken this pair, we can pick another pair, for example this one, sine 104.04 over 1.8, because the reason why I'm taking the blue one is because we need to find the speed, and therefore it's the speed that I'm putting here. So in order to solve this, I will just swap them around. So sine 66.66 times 1.8 over sine 104.04 is equal to z. So in order to get z, I have to get sine 66.66 times 1.8 divided by sine 104.04, which will give me 1.7. So that's the speed. So in order to get the time, I have to use distance, which is 82.46 divided by the speed, which is 1.7. So 82.46 divided by 1.7 will give me 48.5. And to know what unit I should put for the sine, this is in meters and seconds, so the answer will be 48.5 seconds.